Alright, so let's talk about recursion. So this video we're going to show you recursion and the technique of recursion and why we need it. So it's a technique that leads to the solution of the problems for the problem that is difficult to program using loops. Alright, so we know that when we use loop, we can do something that repeating over and over again. Sometimes some problem is not easy to deal with. Like for example, if I want to write an application to find factorials of numbers, we know factorial, right, in math. Like if I have 3 facts, 3 times 2 times 1, right? So we can use loop to do that. And beside that, we can express in the term of using recursion. So how do we do that in recursion? So in recursion, we said we should have the base case, which is the algorithms for factorial going to be in a function called factorial. And the base case is pretty much when it gets to the, like we said, 3 times 2 times 1 times 0 fact. So 0 is the base case, which 0 fact returns 1. Right? So, and else pretty much just going to call a smaller version of itself, like call its own function. Like function named factorial, and smaller version is pretty much just, if I try to find 3 fact is 3 minus 1, so I try to find 2 fact. 3 times 2 fact, right? And then itself, I guess, going to call itself again, right? And pretty much just 2 times 1 fact, and 1 times 0 fact, which is return 1. So that's the best case, right? So it's just repeating by calling itself over and over again. Now this is an example of the code. So we're going to create a factorial, right, methods that take n, and base case is going to be where it's equal to 0 returns 1. And this is called recursive call. So recursion happens here by its call itself. So call itself by passing a smaller version of itself. So this is called recursive, right? And when you use this in application, pretty much just pass that into the method, like enter the numbers and then n passing it to find a factorial. Alright, so now if you look at this image, just try to explain like step by step, right? If I want to find factorial of 4, we pass 4 in. And it's going to do else case here, right? To go to recursive because it's not equal to 0. So it's going to go to returns n times 4 minus 1, which is 3 factorial. So that's why it's just say 4 times, right, factorial 3. And factorial 3 is going to do the same recursive 3 times factorial 2 and 2 times factorial 1 and 1 times factorial 0. 0 is the best case, which is going to go into this returns 1. So that's why we going to return 1. That's the stopping point, no longer recurs. See, right? And then when we get 1, it's just return the values back. You see that we cannot calculate yet until we get the values that returning back. And if you look at this image, so we're going to have a stack. You see that stack? This is using a stack, pretty much using a stack, right? To stack the values like 4, 3, 2, 1, and 0. And we still have this in the memory. So it's occupied a lot of spaces, like stack. And then pop out when it returns pop 5, then get 1, and keep popping, right? Popping and popping until the end, then you get the answers back, right? By multiplying. So we're using stack here. So this will cause the stack space to be dynamically changed, right? And we understand stack, and we understand how to implementing that. We can use array and or linked list to implement, right? And this is pretty much just application. We can make it recursive call using stack. And sometimes you may heard about stack overflow errors, right? So, like if you look at this, simpler and more efficient to implement factorial method using a loop. Loop actually better. Okay, we just use this to explain recursive because it's easier to look at. However, we use recursive factorial method here to demonstrate the concept, right? Some problems that are inherently recursive and are difficult to solve without using recursion, we will see that later. Recursion does not reduce the problem in a manner that allows it to eventually converge into the best case, or best case is not specified. So if you never specify the best case, that means, like in this case, there's no if, right? For the best case, so that means it's going to be infinite recursion. Because never stop. Keep calling to the negative, right, version and keep calling. So this will create a stack overflow, which is you no longer have enough memory, right, in your RAM, right? Let's look at another example. If I want to write an application to find and compute the Fibonacci numbers. So we said recursive is going to help make it intuitive, straightforward, and simple to solve this problem by using recursion. So what is Fibonacci numbers? Let's say we have a series of numbers, right? Which going to begin with 0 and 1, and each subsequent of number is the sum of the preceding two. Like 0 plus 1 we get 1, 1 plus 1 we get 2, 2 plus 1 we get 3, 3 plus 2 we get 5, 5 plus 3 we get 8, 8 plus 5 is 13, and so on. So this is called Fibonacci, right? We have all the indexes. So if we have to use loop to write this program, it's going to be a little bit more complicated than using recursive. So that's why we said, okay, sometimes we want to trade off with this, right? The memory with complications, right? By using recursive. So by using Fibonacci, recursive to solve this, we said, so we're going to have, when Fibonacci is 0, we're going to return 0. Fibonacci of 1, we're going to return 1. We call fib1, fib0 here. And then we know that the next one is depending on the previous index, right? Subtract by, like, previous 2. So 2 and 1, right? Those are previous 2. Those are index, right? Like for example, if I want to look at 3, we know that it has to add between index 2 and 3, right? The values of those two index. So that's why we subtract by 2 and 1. Whatever current index is a 4. Subtract 2, you get add index 2. Subtract 1, you get add index 3, right? And also, index must be greater than or equal to 2. Right, when it's getting to 2, we get index 0, which is 0 back, and 1, which is 1 back. And that's very simple. And then we can just create a function with, right, this is with two best cases, right? When case at 0 returns 0, case at 1 returns 1. So those with two best cases. And then, otherwise, we're going to do recursive, right, calls, and return that summation of those. Fibonacci that called itself. And this is an application. We just put them all in applications. And that is very simple instead of using loops. So that is pretty much the pros of using recursive here. Right? Recursive implementation of the Fibonacci method is very simple and straightforward. But it's not efficient, since it requires more time and memory to run recursive methods. So it said better one, you should use the loop. That gives you more efficiency. So let's see.